The three-phase motor is by far the most powerful of all the motor types discussed here. These motors have an extremely high starting torque and do not require the use of capacitors. Three-phase motors require three-phase power supply, which feeds three hot legs to the motor. Each of these three phases is 120 electrical degrees out of phase with the next, creating a very high starting torque and a high running efficiency. Many three-phase motors are designed to operate at different voltages to satisfy different system requirements. Three-phase motors can be internally wired as either a star or delta configuration. The star configuration is often called a Y configuration. A motor that's configured as a star will have a schematic similar to the one shown here, and is field wired according to the voltage that will be supplied to the motor. The high voltage connection configures the motor windings in the shape of a large Y. Power is supplied to wire leads T1, T2, and T3. When the motor is to be used at the lower of the two voltage ratings, the windings are connected to form two smaller Ys, which are wired in parallel with each other. L1 is connected to both T1 and T7, L2 to T2 and T8, and L3 to T3 and T9. The delta configuration can also be used at either voltage rating. When used at the higher rated voltage, the motor is field wired so that the windings resemble a large triangle. T6 is connected to T9, T4 to T7, and T5 to T8. Power is supplied to the motor through T1, T2, and T3. At the lower voltage, the windings are configured as two smaller triangles wired in parallel with each other.